Okay, so let's wait for another 5 minutes to see who else is coming in, right? Then we start the class. Okay, so good morning. I will finish up chapter 3 today. So which means that once I finish chapter 3, I can let you go. Um, we will discuss on the self-test 2 first, to see if you have completed the work, all right? Because last week, if I'm not mistaken, I stopped in self-test 2, right? I asked you to finish up self-test 2 at home. Okay. Um, okay. So, any problem with self-test 2? Can you hear me? This is so will never stop. Can you hear me?
Yes.
Okay, I cannot see the chat. If I were to open the chat, I need to come back to this again, and it's just
Yeah.
wasting my time. So you just unmute and speak to me, okay? So the one you can see that, okay, thank you. So the one you can see that here, this question. So first thing is to XOR whatever value in AL with 79. So when I ask you to do such question, you have to change whatever in the AL. So you can see in AL, I have C and D. Okay, so I convert C and D into binary, I convert 79 into binary, and I do the XOR. Okay, and I get the answer. So this question, they never ask you to check on flex. So basically, you just need to tell me the result after you do the XOR, and then you just continue with where the register in which register it will be stored. So in this case, when I do the XOR of AL and also 79, I get the answer as 1011 0100, and the answer will be stored in AL. The next one, rotate. So like I said, you need to move the number of time that you want to rotate into the counter, and then you do the rotate as per what is given, rotate to the right, the DX value by 4 times, and then here they didn't show each one of the rotation, but once you finish rotate, you should get this answer, and the answer will be stored in DX. So same goes to OR, OR. Okay, OR is very easy. As long that it's not 0 and 0, the rest of the answer will be always 1. Okay, and for N, both of the input should be 1 for you to get 1. Either 1 is 0, you get 0. Both 0, you get 0. Okay, so you need to store this in AX. Then you can see that the next one, you rotate through carry left. And for this case, you need to set the carry flag as 1. Okay, and then you rotate 3 times and you get 7F, and then you can see in your carry flag is also still 1. Okay, so any question about self-test 2? Do you have any questions about self-test 2?
Miss, can you repeat on the move and rotate one?
Question number?
Question at the last slide, previous slide. The question number 2.
Number 2,
Yeah.
Question number 2, you need to convert DX. If you see the value of DX is 2345, right? You convert 2345 into binary, and then you rotate every single time to the right. Okay, now let's say I ask you to, okay, so 2345 in binary will be 0010 0011 0100 0101. So if I ask you to rotate to the right, the one on the right will be out. Okay, the one on the right will be out, right? So we move that last one to here, and then we have 001 0001. Then this one 010 will be the next one. And then
this
we have...
This one I know how to rotate lah, but how do we know how many times do we need to rotate?
Here we already give you the value 4. Move
Also
4
need to,
into CL. So basically
also
when you
need
move
to
something
rotate
into
4 times.
Yeah, if you move something into CL or let's say CH or whatever, then that is the number of values that you rotate. You rotate this 4 times. Okay, so in this question you rotate for 3 times.
Oh, okay, I understand.
Okay, right.
Okay, thank you.
Okay, so that's it about this self-test 2, arithmetic and logical. So I'll move on with the 8086 memory map, right? Is there anyone else in the lobby? Can someone please help me to accept your friends if they come in late, because I cannot keep on changing my screens over here. Okay, so if you take a look on this 8086, can you see my screen? Can you guys see my screen?
Yes.
Okay, all right. So if you look at this 8086 memory map, all right, this is okay, like I said, like I usually say, try to imagine your memory, the computer memory, as if it's in like blocks like this. Okay, and if you notice the 8086 memory map, this is in 8086. So now we might have something different kind of structure. The structure looks like this, where you have open memory from the location 80 hexadecimal to FF FEF hexadecimal. So this part is basically used for, if you want to execute something, it will be put into this, something like that. Okay, then we have reserve memory, we have dedicated memory. So the reserve and dedicated normally used for interrupt. So which I will explain to you later. In the previous, in the chapter 6 or 7, we will talk more about interrupt service routine. Okay, and when you look at top part over here, from location FFFF0 hexa to FFFFF, this is dedicated for the use with future products or maybe dedicated functions such as hardware reset, meaning that let's say if I want to do 2 plus 3, I can only do it in the open memory map. I cannot disturb whatever is here, whatever is here. Okay, because it's already dedicated for something else. Okay, so that is the memory map. Okay, right, next. Then we have the address and data organization. So remember, I told you from the beginning of 8086 processor, there are 20-bit address bus. So you can store up to this is 1,048,576 memory locations. There are about 1 million memory locations basically. Okay, they support about 1 megabyte of memory. Okay, so the range of the memory address are from 0000000 so to 11111. So if you notice, right, if you look at the previous slide, the first one, it starts at 0 hexadecimal up to FFFFF. Okay, so that means this is the address basically in hexadecimal. Okay, so to easily to read basically. The memory subsystem can access 1 or 2 bytes, where any 2 consecutive bytes can be accessed as a word. So the lower byte is what they mean as the last 8-bit. Okay, so we have 1 byte is equals to 8-bit. Am I right? So if it's a 2 byte, it is equals to 16 bits. So 16 bits is equals to 1 word. Am I right? So if you have two, if you take a look at this point here, if you have 2 consecutive bytes, it can be accessed as 1 word, which is 16-bit. So now let's talk about the lower byte. The lower byte is what we call is the less significant, while the higher byte is what we call as more significant. The most significant bit and the less significant bit. Okay, the least significant bit. All right. So, and this is what we call as Little Indian byte ordering. So what is Little Indian byte ordering? Can I type something here? Okay, I show you in my notepad. So this is the description of Little Indian byte ordering for you to take note. Okay. So it's also known the least significant byte value. Significant byte of a value is stored first in memory. So this gives the appearance okay, what is the meaning of this, right? Actually, when you look into some other slides in future, you will see that you read the memory address as if it's in a backwards, meaning that, okay, let's say your address is something like so for example, this is the address, right? Memory address, we have memory address of 184 185, 186, 187. So normally if let's say if I ask you to store a value of, let's say I ask you to store A, B, C, D, 1, 2, 3, 4, example. Okay, I ask you to store this value into the memory. Okay, so what happened is normally we assume that it will be stored in a something like this. So there is A, B, C, D, CD, and then 1, 2, and 3, 4. Okay, so this is what we call as the big Indian byte ordering, which we don't cover this basically. But we will cover Little Indian byte ordering, where it gives an appearance of the numbers are stored being in memory backwards. So meaning that I store the values from the lower significant bit, meaning I start at 34, 12, CD, AB. So when I read this, I will read from here, but then it is, okay, how do I explain this? It's something like you read from here, but then when you put it into this method, you will put it this as the lower significant bit. Okay, so this will be useful when you actually do your next chapter. Where is my next chapter? Okay. When you want to do the next chapter, which is here. Okay, so in this next chapter, we will look into how to read the memory, something like this. Okay, something like this. So it will be useful to read memory like this. Okay, so yes, something like this. Okay, so in case if you have questions in final exam, this is how you read it. Okay, you don't assume. So some students, if you don't follow this right now, okay, you might thought that, oh, reading this, it shows that I should read like this. Okay, when you look at this, but actually no, but you should be looking at the first memory address. Okay, if let's say the question asks you to read that the value from memory location 184 to 187, by right you should be reading it in a way that 34 will go to the lowest significant bit, okay, followed by whatever that is in the most significant bit. So this is the way of reading in 8086. Okay, and we call this as Little Indian byte ordering. Do you have any questions about this? Anyone? Before I move to the next one?
Yeah, okay.
Okay. All right. So I move to the next one. So I'll just skip all this because the end story of all this is actually on how to read, okay, how to calculate the physical address, 20-bit physical address. Because if you notice, right, I told you, remember at the beginning of this chapter, I told you that the 8086 will start as a 16-bit address, logical address, but then when you push a value into the here, when I tell you this something here, when you push the value into the registers, it will be added and become as 20-bit address bus. So how to calculate this, right? So go back here to this slide here where we have, okay, memory address generation. So the BIU, okay, bus interface unit, they actually have what we call as a dedicated adder to determine the physical memory address. Okay, so you will need to take your segment register and you multiply with 10, and then you will get plus with any of the offset value, and you will get your physical address. Okay, I got. Okay, so you can see, for example, right? Okay, so the hardware memory address of the 8086 is 20-bit. So this is usually what we call as a physical address. And the memory address used in programming is called as logical address, and it has only 16-bit. Okay, so this is because the register size of 8086 is only 16-bit. So it can only hold 16-bit address. Okay, so to solve this problem, they use the concept of segmented memory. Actually, we will learn more on segmented memory in chapter 6 also. Okay, so the 20-bit address is generated from a 16-bit base value and a 16-bit offset value. So how do you know how to decide the offset value? It is depends on the type of memory reference. So you remember I told you guys to remember to memorize something like this. So I said CS should be always paired with IP. Okay, then remember I told you to remember DS is always paired with, anyone remember? DS is always paired with Hello? Okay, let me just give you some idea first. Okay, so just now I said base value. Am I right? So base value need to be paired with offset address. Okay, so when I talk about base value normally comes from CS, DS, ES, and SS, which is your code segment, data segment, extra segment, and also stack segment. Okay, so now when we talk about offset address, it will come from your BP, which is base pointer, your base register, which is BX, your source index, destination index, and instruction pointer. Okay, so this is where it will come from, right? So if you remember, I told you CS will always pair with IP. Okay, and then DS will pair with the first few slides. I told you to memorize this. Anyone remember? DS will pair with
SI.
SI, okay, or
DI.
DI, or another one is
Yes.
BX, correct. Okay, next we have SS, okay, which can be paired with stack segment, can be paired with
SP, BP.
SP or BP. Very good. Okay, so you have to memorize this. So now let's assume I give you a question and I ask you to calculate the physical address of this particular code, right? So the answer will, okay, let's say the question looks like something like this. Okay. The question looks like this. Okay. Okay, move DI, whatever in the AL. Okay. So assuming not AL, okay, let's put it AL first. Okay. Okay, and I give you the value which is, let's say CS is equals to 2000 hexa, and I say DS is equals to 3000 hexa, right? Then I give you SI is equals to 4000 hexa. Okay, and I say DI is equals to 5000 hexa. Okay, and then the next thing I give you is AX. The value I have in AX is A, B, C, D, hexa. Okay, so now I want you to find out the physical address of this. The formula to find the physical address will be your segment times 10. Okay, so I put it into bracket, plus everyone is online. And why are you here? Go sit outside, join online class. Plus the offsite value. Okay, so segment, the value of segment. How do I know the value of segment? So what do DI pair with? Usually what DI pair with? Based on this, we know it's data segment, right? So the value of data segment here is 3000. So let's put it here, 3000 times 10 plus with the offset value, which is your DI. So my value of DI is 5000 plus 5000. So what is my total here right now? Anyone can give me 3000 times 10? Hello?
35,000.
Sorry?
35,000.
35,000. Okay. Actually, 3000 times 10 is 30,000 plus with your 5,000. Now, my physical address of this is 35,000. Okay, so we already find the memory address of 20-bit memory address, which is 35,000. Okay, hexa. So what do I move into the 35,000 right now? So look at my code here. I'm going to move whatever inside AL into this location. So I already find the location of this, which is 35,000. So what is inside my AL right now, guys? Can anyone tell me what is inside my AL?
Is this CD?
CD, yes, CD will be stored in location 35,000 hexa. This is how you answer your question. If I give you a question like this, the idea here is to look for the 20-bit physical address. So how do you find a 20-bit physical address? You need to use this formula, all right, to calculate the physical address. And then once you get the physical address, you need to store what is being moved into here to the physical address. You need to give me the answer like this. Is that clear so far? Is that clear? Can I try another one with you guys?
Yes.
Okay, let's do another one. Now let's say if I give you a question, okay, let's say I give you something related to, okay, SP plus H. Okay, then I give you, I said move the value of AX. Okay, so how do I do this? Again, we use the formula segment times 10 plus with the offset value. Okay, so what is the segment for SP? What segment pairs with SP? Anyone? I want answer from you. Hello? What segment pairs with SP? Looks like I need to call your name, huh? Or maybe I should ask everyone to turn on camera. Ang Jingwen? Can you hear me? Ang Jingwen? Yes, and Ang Jingwen. Can you tell me what segment pairs with stack pointer? Hello? You want to answer? Teo Ik Chun said SS. Okay, yes, SS is a stack segment basically. SS, alamak. So SS, what is in my SS, guys? What is in my SS?
4,000.
4,000. Is it? No, I didn't give you SS. Sorry, SS. Let's assume I give you SS 8,000. Sorry,
Yeah,
yeah.
8,000.
SS is 8,000. Sorry. In my SS, I have 8,000 times with 10. Okay. So it's going to look like the plus with the offset value. What is in my, oh, I don't have SP also. Okay, SP, I give you 1,000. Okay, in my SP, I have 1,000 plus with 10. Can anyone give me the total of this?
81,010.
81,010. Correct? Any arguments on this? Anyone would like to argue that this is incorrect?
No.
1,000, yes, correct. Okay, so how do I store? So I'm going to store, previously I store only 8-bit value. This is 8-bit, am I right? But here I'm going to store 16-bit value. Okay, so that is one difference that you have to notice. So if I want to move 8-bit data into one location, this answer is okay, fine. But let's say if I want to move 16-bit answer into the location, here comes the trick, okay? So how are you going to store is the content of AX is the content of AX is A, B, C, D, right? Okay, so what you do is you put it this way, 81010 in, okay, so in my 81010, I'm going to store which 8-bit? Which one of these 8-bit? I can only store 8-bit of value into one memory location. So am I going to store AB or am I going to store CD? Which ones am I supposed to store?
Suppose CD.
CD, correct. Okay, so next you increment one location. So when you increment, right, 81011 hexa, here is where you store your AB. So don't you think this thing here right now, it's actually going back to your Little Indian by ordering. So in your Little Indian by ordering, remember I told you the least significant bit will be stored first in the first location, then followed by the most significant bit. Okay, so this is how it works. Is that clear? How to calculate this?
Yeah.
It's very easy. Okay, one more question. Okay, let's say I give you something like this. Okay, I need space. Can I have new notepad? Okay, so put it side by side so you can refer to this. Okay, let's say I give you BP and SI. BP and SI. Okay, BP and SI. Okay, and then I plus with 10. And I ask you to move the value of AX. Okay. All right. So this is one question. So I need to give you BP here. Let's say I give you BP. BP will be 1, 2, 3, 4, 5. Okay, 6,000 hexa. Okay, can you give me the answer for this? I want to test you guys. Okay, it's very tricky. Okay, but I want to see who can give me the correct answer. Can you try this? I give you 5 minutes, huh? Okay, so did you manage to finish this? Can anyone give me your answer? Let's check whether it's correct. It's okay if it's wrong because I know I haven't teach this yet. Anyone would like to try to see if you're correct? Hello? Okay, then I'll just call names. Chen Hao?
Yes, miss.
Yes, Chen Hao. Do you have your answer?
No, I don't know how to do.
Okay, never mind. Wei Jun? Goi Wei Jun?
Yes.
So do you have answer?
No.
No. Okay, let's try another one. What about then go down. Tan Chi Kwan? Oh, Teo Ik Chun got give me answer here. So this is your answer, Teo Ik Chun. Okay, never mind. Someone gave me answer. Okay, thank you, Teo Ik Chun. Right, so your friend here they give this answer. Okay. All right. So how to solve this? Okay. Very good, Teo Ik Chun, for trying. Right. So for BP, right? Can you tell me what is the segment that pairs with BP? The segment that pairs with BP. Anyone? Hello? The segment that pairs with BP?
6,000.
6,000, the stack segment, right? So it's actually stack segment that pairs with BP. So when you actually, right, when you notice this question, you have two different registers over here, correct? So if you were given more than one register over here, you only need to find the segment that pairs with the first register. So the SI, you no need to find. Okay, so in this case, you only find the segment that pairs with BP. Okay, which is 6,000. Okay, so your answer should be 6,000 times 10. Okay, and you plus with whatever for the BP, which is, sorry, SS is 8,000, not 6,000. Plus with your BP, which is 6,000, plus with your SI, which is 4,000, plus with, look at this 10, I never write H over here. So this 10 here is a decimal value. Okay. So if I were to convert decimal 10 to hexa, okay, what will be my answer? Decimal to hexa. Anyone? 10 decimal to hexa.
A.
A. Very good. So you got your A over here. Okay, that's it. So when you calculate this, you will get 80,000. I need my pen. It's difficult to calculate here. What is the total here? So it should be 80,000 plus with 6,000, you get 86,000. Then you plus with your 4,000, you get 0, 0, 0. 6 plus 4 is 10. So you bring 1 on this side. 6, 4, 10. So 1, 8. Should be 1. It should be, how do I do it now? Okay, I need to calculate this. Wait, 20,000, 5,000, 5,000, 60, 80. Oh, okay, so the 10 will become A. Sorry, 6 plus 4 is 10, right? So it will become A and it will become 8A000. So then you plus with another A, correct? Then the answer will be 8A00A. Okay, so it's like this. So 80,000 plus with 6,000 and you get 86,000. Am I right? Okay, then you plus with your 4,000. So when you plus with 4,000, so you get 0, 0, 0. 6 plus 4 is 10. So 10 in hexa is A. So your answer will be 8A 0, 0, 0. Okay, then you plus with another A. Am I right? Which is your 10. So the total answer will be 8A 0, 0, A. Okay, so this is your final location. Okay, now I need to move AX into 8A000A. So what will happen here? In my 8A00A, I will store CD. Okay, and in my, what is the next number? What is the next number? 8A00. Anyone?
B.
B, correct. Okay, you will store A, B, XR. This is the answer. Okay, is that clear? I think you do more exercise on this, you will able to answer this perfectly. So it's a bit, this one is a bit tricky. This is a tricky part. That's why for this question, right, if you get in final exam, each question will give you 4 marks. And in August semester, we had this question in final exam, and out of 80 students, I only had 2 or 3 students scored 20 marks. The rest only score like 2 marks, 3 marks, like that. Okay? And unfortunately, when I teach this, you're online right now. Okay, never mind. But I think this, is this okay? Anyone not clear? Anything? Anyone? Can repeat again. Sonia, you come and see me, Sonia. Okay, what you do is, now, I am going to let you guys to finish. Okay, actually we are done the slide. So it's actually whatever that I just discussed with you. They put it in a slide here, right? I need you guys to work on self-test 3. Okay, this self-test 3, can you do it until 12:10? I give you 20 minutes. There are 5 questions. Don't look at the answer. You look at the answer, you definitely cannot understand. Okay, so you, without looking at the answer, try all the 5 questions, then we discuss the answer at 12:10. Okay, work on this. Okay, so let's go back to this, right? Just clear this whole thing. Okay, let's take a look at the question. Can you hear me? Can you guys hear me?
Yeah.
Okay, so the first question is to move whatever in AL into the SI. So you need to calculate the physical address of SI first. So if you look at the question, we need to pair DS with SI. So it should be 20,000. So we just straight write 20,000, no need to multiply all that, plus with whatever value in SI, which is 4,000. So it will give you a total of 24,000 hexa. So AL is 8-bit. So easy, 24,000 hexa. We store what is in AL, which is FF hexa. Okay. Number 2, question 2, move DI plus with 6 hexa, and you move BX into it. Okay, so for this question, the segment that pairs with DI would be DS. Okay. So the value of DS will be 2,000, which is, so 2,000 times 10 will be 20,000, plus with the value of DI will be 5,000, plus with 6. So 6 is hexa, all right? So easy. So the total will be 25,006 hexa. Okay, so you need to store 16-bit into this memory address. So that means you need to increment by 1. So 25,006 and 25,007. Okay, right? So when you store the answer, in the first location, you store the last significant bit, which is 80 hexa. And then the most significant bit goes to the next address. So far easy, right? This one is easy. Am I right? Okay, so the next one. So here to with SI, you are going to pair with DS. So it's going to be 20,000 plus with what is in your SI. It's 4,000 plus what is in your BX, 6080, and you minus with 8. So can you give me the answer for this? What's the answer for this? 24,000 plus 680. So we got 24,000 plus 6080. So you get 0, you get 8, you got 0, you got A, and you get 2, right? Then you minus with 8. When you minus with 8, you actually minus 16 minus 8. Okay, so it should be where, okay, so this one, right? Okay, each one of this value is actually 16 because it's in hexa. So remember, this is in hexa, it's in hexa, hexa, and hexa, right? So if you want to minus this number with this one, you cannot minus this. Am I right? So what you do is you minus, how do you minus is you need to borrow from the previous number. So when you borrow this, this will become, over here, it will become, can I edit this? Okay, so it's like you cut this and then it will become 7. This is 7. So here you minus with, it became 16. Okay, so 16 minus 8, your answer will be 8. Okay, so now this will be 7, and then 0, then we have A and 2. It should look like this. Yeah, okay. Do you understand what I mean over here? Put it into Notepad, Word document is easier to see. Okay. So we have this, right? The formatting will be a bit. So we minus with 8. Okay. So what will happen here? Okay. Okay, I need to remove this. So you cannot minus this with this. So I'm going to cut this off and this will become, on top here, it will become 16. So 16. Okay. Get smaller a bit. Okay, and then here, you need to cut this and it will become 7 on top here. Okay. Okay, so there you get the answer. 16 minus 8 is 8, 7. You just bring down and then you get the total answer. So you get 2A078 as the first location. In 2A078, I will store FF XR and then I increment 1 to A079 and I will store 25 XR. Is this clear with you guys? Any questions on this? Okay, good. Right, so move on to question number 4. Move DI and then BX plus with 28 XR. You push the value of CX into this. So DI we pair with DS, all right? So you will get 20,000 plus with what is in my DI? 5,000 plus with in my BX, I have 6080 plus 28. Okay, so the total will be 25,000 plus with 6080. So here I will get 5 plus 6 is 11, so B 080 plus with 28. So I will get 2B0A8. Am I right? Okay, so in my 2B0A8, I will store CX, right? So CX here is 16 bits. So we store the last significant bit, which is 91. And then I plus 1 2B0A9. I will store 87 hexa. Okay? Any questions on this? Anyone? You don't know how to answer? You're okay? So can we go to the last one? Right, the last one for BP, you need to combine with SS, and the value of SS is 3,000, which makes it as 30,000. Then you plus with BP, which is 7,000. You plus with SI, which is 4,000. And you plus with 10. So it's easy. So 30,000 plus 7 is 37,000. Then you plus with 4,000. 7 plus 4 is 11. 11 will be B000. Okay, and then you plus with 10. You get 3B010. Okay, so that's your final answer. So you need to move DX into 3B010. So what is in my DX? The first one, what do I move into 3B010? You must write H, huh? Don't forget to write hexa here to indicate it's in hexa value. So what do I move into 3B010? Aruvendra? Are you there? Aruvendra? Oh, how I miss Blackboard Collaborate. I can actually come and nudge you, disturb you. Aruvendra? He's not there. Aruvendra, you're not there. Huh? What about Eugene? Can you give me the answer for this? Eugene Lim? Count a second. What you need to count? You just see the answer here is enough. You just give me the answer. There's nothing to count. I already count. Aruvendra, give me your answer, Aruvendra. Yes, Teo Ik Chun, thank you. So 3B010, we store 99 into 3B010. And 3B011 hexa, we store 12, right? If I'm not mistaken, what was the question just now? 12, yes. That's it. You get 25 marks if you answer 5 questions. Easy, right? Okay. I think that's all for today. We are done with chapter 3. So next week, I will move on to chapter 4, right? So chapter 4, I can finish in 2 hours. Finish with that. The following lecture, we will be doing midterm. Okay. So please make sure your attendance is there for the midterm. Right. And I will... Oh, this Friday lab is online. The class will be online this whole week. So you will only come back for a face-to-face next week. Okay, attendance. Okay, I call for your attendance first. So, ITN students. The group assignment, can you wait? Let me take the attendance. Don't leave the session first. I will brief on the group assignment also. Okay, so Aruvendra, Benjamin. If you don't, I will call your name. So I need you guys to unmute and say you are here. If you're not responding to me, I assume you're absent because basically you just turn on the session and you leave and you go somewhere else, you do something else. I'm not going to respond to any chats here.
Yes,
So
miss.
Aruvendra, Benjamin, not here. Chantayu,
Here.
okay. Then Chia Wenshen, Chen Hao,
Yes, miss. Here.
Eugene Lim,
Miss.
Justin Wong,
I'm here.
Kelvin Chan,
Yes, miss.
Lawrence Tan, Lee Wei Liang,
Yes.
Neo Junkai,
Yes, miss. Yes.
No Amalina,
Yes, miss.
Hui San, Hui San, Rachel Ng, Sir Lee Hen,
Yes, miss.
okay,
Sorry, just now my mic is not working. Sorry.
Okay, Hui Uisan, right?
Yes.
Okay, Sailesh,
Yes, Miss.
Sim Tiansen,
Hello, I'm here.
Tan Chi Kwan,
Yes, Miss. Yes.
Tang Kaiser,
Yes.
Teo Junji,
Hi, I'm here. I'm here.
yeah, and Yong Ying Sun.
Yes, yes, I'm here.
Next. Ahmad Zafri, not here. Alvin, not here. Amos,
Yes, Miss.
Brandon Yo, Brandon, chat. I don't want chat, Brandon. Oh, okay. Chan Jiazuan,
Yes.
Chang Yuzhen,
Yes.
Cheong Yi Kwan,
Yes.
Liu Zibun, Claire,
Yes.
Desmond,
Yes, Miss.
Divagar, Divesh, are you there?
Yes.
Okay. Gui Weijun,
Yes.
Hayden Tay,
Yes.
Justin Ong,
Yes.
Kang Han Yi,
Yes.
Hu Teng Jae, not in. Ko Iwei,
Yes.
Lawrence Wong,
Yes.
Jala, not in.
Yes.
Leong Hong Kai, Jala, are you in?
Yes, yes.
Oh, it's Hong Kai, Leong Hong Kai. Lau Justin,
Yes, yes,
Muaz,
yes,
Ng Jing Wen,
Yes.
Nicholas Chai, Nurul Ashwin,
I'm here, Miss.
Ong Chiao Yuan, Ong Chiao Yuan, not here. Ui Wei Chia,
yes,
P. Ida,
Yes.
Rachel T, not here. Ryan Go,
Here.
Sonia,
Yes.
Tan Lisa,
Yes.
Tan In Win, yeah. Yes, Nurul, I hear you. Tan Yin Win, okay. Teo Ik Chun,
yes,
Thomas,
Yes.
Wong Kai Jun,
Yes, Miss.
Woon Fu Yang, and Yu Wen Jun.
Yes.
Woon Fu Yang, okay. Okay, wait. Okay, the assignment. So if you go to your canvas, let me open my canvas first. So if you go to your canvas, right? I actually uploaded your assignment. Did I post announcement on this? Yeah, okay. So I already uploaded assignment for you guys. Okay, actually, group assignment, this is the link for DCS students to submit. This is the link for DITN students to submit. But actually, it's the two same assignment. You just go in, download the guideline here. So when you click to download the guideline, you need to group yourself into 5 students in group. It's a different. Why go to lab report? Yeah. Okay, I think something wrong with the submission. I remove this. Wait, I upload right now for you. How come can go to wrong one? Assignment. Submit. Okay, so I save this. So I click this. Okay, I should be able to see group assignment now. Okay, so you just group yourself into 5 students in a group, and the submission date is on 30th June. Okay, so what you need to do is you write a technical report on the following topics. Okay, so when you write, okay, the question may look easy, but when I say technical report, it's all about how you compare and come to a conclusion that which is better. If you look at the questions here, why is RISC architecture best used for pipeline processing and CISC? So you have to compare these two and tell me why RISC is better. So one thing that I actually get from the previous group is there is no comparison. They just straight away go into, oh, RISC is better than this because of this. But they never explained about CISC. So you don't do the same thing. If you want to get good marks, there should be a comparison. There should be a critical analysis. Okay. So same goes to advanced level. It looks like very easy to build a computer. I can just write a components like a motherboard, RAM or something like that. That's it. But if you want to come to a comparison, to a final conclusion, you should do a comparison. You should compare and justify what are the technologies that's available. And then you give me some sort of like a final conclusion that this is the best among all that is available in the market, something like that. Okay, so that is what you're supposed to write. It's just a report, but it's a report. It's a group work, 5 students. Everyone need to contribute, because if you notice here, I actually uploaded job allocation table. So you need to download this job allocation table, write everyone's name and tell me what have you done for this assignment and what is your percentage of contribution. Because trust me, this is your first semester, but normally there will be at least one student who is a sleeping partner in your group, okay, where they don't do anything for the assignment. Okay, so what you do is make sure that you submit this job allocation table, you submit your report, and you must also submit your Turnitin report. Okay, so how do you submit your Turnitin report? You just go here. Before you submit into this link, you go to your Turnitin link, upload your report here, generate the plagiarism percentage, get the report, download it, and then you go and upload into the DCS link, to the link. Okay, so make sure when you click here and you want to submit, right, you must submit 3 things. One is your report, one is your Turnitin report, the other one is your job allocation table. So there are 3 things that you have to submit. Is there any question on this? Only one student need to submit representing the group. So no need everyone to submit, only one student. Okay, so let me check the DITN student link also, just to check. Is this a group assignment? Yes, this one is correct. Okay, so groups. How do you go for a group? You click people, and then you go to grouping DCS student only or DITN students only. All right, then you go and join your group. So you can usually see those who is elected over here, they are the group leader. So what you can do, maybe you can choose this person to submit your groups. Okay, next thing, I can see some of you haven't have any groups yet. So I give you time until next Wednesday. If you don't find yourself a group here, all right, the ITN students also until next Wednesday, I will put you guys into the group. Okay, randomly. So if you don't want me to do that, you better do it yourself. Is there any question on the assignment? Do you have any questions?
No.
Okay, so if you have any questions, you can ask me in class next week. For now, your job for the next 1 week, go and find a group. Okay, so thank you, and I'll see you guys next week.
Okay, thank you, Miss.
Okay,
Thank you, Miss.
bye.